Hello friends, let me welcome you all to my fourth video on the chapter alcohols, phenols and ethers, right? In the previous video, we discussed something about physical properties of alcohols. Physical properties of alcohols we discussed, and that we discussed something about solubility and boiling point of alcohols, right? Now today's discussion, we'll start the chemical properties of alcohols. Right? And as far as chemical properties are concerned, a chemical property of any organic compound depends on the structural formula. That is arrangement of the atoms in a molecule of a substance, right? In the molecule of alcohol, you can find here we have two kinds of bonds. One is that is OH bond, another is CO bond, right? Here we have alcohol sally OH bond ide matte CO bond ide, right? There are some chemical properties where you will find it is cleavage of OH bond takes place, right? In some chemical properties, you will find the cleavage of OH bond takes place, right? In some chemical properties, you will find there is a cleavage of CO bond takes place. So now, first of all, properties of alcohols due to the cleavage of OH bond. Properties of alcohols due to the cleavage of OH bond, yes. And of course, in such type of chemical reactions, look here, if I say this is OH, that is ROH, right? This is alcohol, right? And when alcohol comes in contact with electrophilic center like C+, any organic compound with positively charged carbon, right? Here, as it contains lone pair of electrons on the oxygen, it will donate electron pairs to the positively charged carbon. Therefore, here alcohol acts like a nucleophile. That you have to remember. Alcohol acts as a nucleophile in the case of chemical reactions where there is a cleavage of OH bond takes place, right? And when if it donates electron pairs to this, you are going to get, yes, look at this, or O, I'll write H below oxygen now, right? Okay, now, as it donates electron pairs to this, oxygen gets positive charge and it will be connected to carbon by single bond, and of course, positive charge of the carbon will be neutralized because neutralized by electron pairs, right? And here, as alcohol donates electron pairs to the C+, it is acting like a nucleophile. Look at this. Here we have OH bond, yes. Due to the presence of a positive charge on the oxygen, which is electronegative. Oxygen is already electronegative and it contains positive charge. Therefore, sigma electrons will be moving towards oxygen to the maximum extent. And therefore, OH bond breaks, hydrogen will be taken out in the form of H plus, and of course you are going to get the product, or O, positive charge is neutralized, and of course C, and this is a product, and of course hydrogen is removed in the form of H plus, that is cleavage of OH bond. This is the general observation in all the reactions where there is a cleavage of OH bond takes place, wherein alcohol acts like a nucleophile. Right? And to this headline, we'll take some examples for the chemical reactions where cleavage of OH bond takes place. I'll take up some examples like yes, it is acidity of alcohols. This is the first property, and that acidity of alcohols, is one example for the chemical reactions where you will find there is a cleavage of OH bond. Yes. And as far as acid is concerned, acid is a proton donor. That means it donates H plus ions to other substances, right? Acid donates H plus ions to other substances like bases. For example, look at this. ROH, this is alcohol, right? When it comes in contact with base like B minus, now the base right? So then it gives H plus to B minus and thereby acts like a Bronsted acid. After giving H plus, gets converted to RO minus. H plus kalkond mele, electron pairs will remain on the oxygen and RO minus agate, and of course B minus takes off H plus and gets converted to BH. Now this alcohol is acting like an acid, B minus is acting like a base, right? Alcohol is acting like an acid, B minus is acting like a base. And of course, after losing H plus, ROH is converted to RO minus. That is, RO minus is a conjugate of acid. I know that in Bronsted acid reactions, in Bronsted acid base reactions, acid after losing H plus gets converted to base. Acid after losing H plus gets converted to base. Therefore, ROH after losing H plus gets converted to conjugate base, and this is what we call it as conjugate base, right? This is conjugate base. If I reverse this reaction, base after taking H plus, it gets converted to acid. This is a base. After getting H plus, it is converted to, yes, it is acid. This is conjugate acid. This is conjugate acid. When you first piece acid after losing H plus gets converted to conjugate base. Base after getting H plus gets converted to conjugate acid. That is conjugate acid base phase or the acid base phase, which differ by 1 H plus. ROH and RO minus differ by H plus. B minus and BH differ by H plus. Therefore, they are conjugate acid base same time. As far as the alcohols are concerned, the acidic strength of alcohol is affected by different factors. No doubt they have got their own ability of donating H plus to other substances, but the ability of donating H plus ions to other substances, that yes, it is different abilities to donate H plus to other substances. That will be studied under the headline acidic strength of alcohols. That is what we call acidic strength. Acidic strength refers to the ability of alcohol to donate H plus ions. Ability of alcohol to donate H plus ion, that is what we call it as acidic strength. Look at this. As far as acidic strength is concerned, ability of donating H plus ions depends on the OH bond strength. ಈ OH bond strength ಜಾಸ್ತಿ ಇದ್ರೆ ಅಂದ್ರೆ if the OH bond is strong, that ability of releasing H plus is less. That means acidic strength is less. If OH bond is weak, ಏನಾಗುತ್ತೆ? Ability of releasing H plus is more. That means acidic strength is more. ಈ ಬಾಂಡ್ ವೀಕ್ ಆದ್ರೆ ಈಸಿಯಾಗಿ H plus ಕೊಡುತ್ತೆ, ಹಾಗಾಗಿ ಅದು acidic strength is more ಅಂತ. ಈ ಬಾಂಡ್ ಸ್ಟ್ರಾಂಗ್ ಇದ್ರೆ ಏನಾಗುತ್ತೆ? That it is difficult for that molecule to give H plus ion. Therefore, acidic strength is less. And that will be decided by, that is strength of the OH bond will be decided by, yes, it is the electron density between, yes, it is O and H. And of course, as far as yes, it is ROH is concerned. Look at this, ROH is concerned, right? And first of all, OH bond is polar because oxygen is more electronegative than hydrogen. This is delta minus and this is delta plus, right? That is polar, and this polar nature is main cause for the release of H plus ions by alcohol. And that is what we call it as acidity of alcohols. Just imagine if this alcohol is connected by any A group. If I connect any A group to the alcohol, A group anna connect martini. Say for example, this A is electron releasing group. This A is electron releasing group anta ankoona. If A is electron releasing group, that is connected to R, that is carbon, that is alkyl group. When electron releasing groups are connected, nodi electrons will be released to carbon atom and then moving like this out there. And what happens, electron density between O and H increases, right? Electron releasing groups are connect ಮಾಡಿದ ತಕ್ಷಣ electron density between O and H increases. If electron density between O and H increases, polarity decreases. The positive charge ಕಡಿಮೆ ಆಗುತ್ತೆ, ಆಗ ಏನಾಗುತ್ತೆ? Acidic strength decreases. ಅಥವಾ when electron releasing group is connected, ಏನಾಗುತ್ತೆ? Electron density between O and H increases, bond strength increases. Bond strength increases. ಆಗೇನಾಗುತ್ತೆ? It is difficult to break that OH bond. Then ability to release H plus ions decreases. Therefore, acidic strength decreases. In presence of electron releasing groups, polarity of OH bond decreases, or in presence of electron releasing groups, OH bond strength increases. Therefore, ability to release H plus ions decreases and acidic strength decreases. That is one conclusion you can have there. Okay, now if I connect electron withdrawing group like, yes, it is B and equal. If I connect electron withdrawing group like B to the alcohol, this is what we call it as alcohol. To that I am connecting electron withdrawing group. The electrons are moving towards B, E direction, opposite direction ಬರ್ತಾ ಇದೆ. All electrons are moving towards B. Yes. If electrons are moving towards B, ಏನಾಗುತ್ತೆ? Electron density between O and H decreases. ಅಥವಾ polarity of OH bond increases. ಅಥವಾ positive charge of hydrogen increases. ಆಗೇನಾಗುತ್ತೆ? OH bond becomes weak. That hydrogen can be easily removed in the form of H plus. ಹಾಗಾಗಿ in presence of electron withdrawing groups, acidic strength when electron withdrawing groups are connected, electron density between O and H, yes, it is decreases. The bond strength of the OH bond decreases. Athwa polarity of OH bond increases. Therefore, acidic strength increases. So totally, on the basis of this, what I can conclude, groups are present, that acidic strength of alcohol decreases. When electron withdrawing groups are present, acidic strength of alcohols increases. And it is the same in all the organic acids. Yavade organic acids allu kuda ide factor bartade. Electron releasing groups will decrease the acidic strength of acids to organic acids. Electron withdrawing groups are going to increase acidic strength of organic acids, and that is what we call it as the different factors affecting on the acidic strength of alcohols. On the basis of this, I am going to compare acidic strength of different alcohols. I am going to compare acidic strength of different. We have different types of alcohols, right? So, for example, look here, right? That is, I go for this or CH2OH, and of course I call it as primary alcohol. This is what we call it as primary alcohol. Apart from that, we have, yes, it is, and this is secondary alcohol, right? This is secondary alcohol. One more type of alcohol, and apart from that we have, and that is, and this is tertiary alcohol. This is tertiary alcohol, right? This is tertiary alcohol. So look here, when electron releasing group is connected, here one electron releasing group is there, but here there are two electron releasing groups, but here there are three electron releasing groups. As the number of electron releasing groups increases, the polarity of OH bond decreases, athava the OH bond strength increases, acidic strength decreases. Therefore, among these three, what happens, this will be stronger acid than this. This will be stronger acid than this. Stronger acid. Primary alcohols are stronger than secondary alcohols. Secondary alcohols are stronger than tertiary alcohols, because in the case of tertiary alcohols, there are three electron releasing groups. The electron density between O and H is very, very high. Bond is very, very strong, and it is very difficult to break this bond. Then release of H plus becomes very difficult. Therefore, tertiary alcohols are weakest alcohols are strongest acids with one electron releasing group. So this is what we call it as acidic strength of, yes, it is primary, secondary and tertiary alcohols. Now at this moment, I am going to give, yes it is one example for the chemical reaction where you will find, yes, it is cleavage of OH bond, athwa that is yes, it is direct proof for the acidic strength of alcohol. For example, react with sodium metal. Yes, when alcohol react with sodium metal, you are going to get, look at this, H is replaced by Na. H is replaced by Na. That means OH bond has broken, and of course with the liberation of hydrogen gas. In order to balance this, we have H2 here, we have H here, therefore make it 2. If I make 2 here, R becomes 2, therefore it is 2. If I make R as 2, Na becomes 2, therefore it is 2. So this is what we call it as balancing equation. For example, in the place of R, I keep this C2H5, one of the alkyl groups. This is ethanol. This is what? Ethanol. Yes. This is ethanol. Yes. This is what? Alcohol. Yes. When alcohol reacts with sodium metal, you are going to get alkoxide, sodium alkoxide. This is sodium alkoxide, and of course hydrogen gas is liberated. Hydrogen gas is liberated. When same manner, R jagal C2H5 hakbidi, and it is 2Na, right? And of course, wherever R is there, you keep C2H5 there, C2H5 ONA, along with the liberation of hydrogen gas, and of course this is sodium ethoxide. This is sodium ethoxide. Yes. So this is what we call one example for the chemical reaction where alcohols act like acids, and of course where there is a cleavage of OH bond takes place. Where there is a cleavage of OH bond takes place. Yes. Now at this moment, we'll go for the second example, that is action of sodium. This will be discussed under action of metals on alcohols. So I discussed action of sodium here. We'll go for the action of, yes, it is aluminium there. Yes. How that aluminium reacts with, yes, it is alcohols. For one information I'll give you there. Aluminium is characterized by plus 3 charge. When it combines with X minus, you are going to get a formula that is AlX3. This is I make use of that particular aspect here. Yes, here when alcohols, right, ROH, right, reacts with aluminium, right, you are going to get, yes it is, right, you are going to get Al, yes it is O or 3 times plus hydrogen gas. Yes it is. Why I have written like this? Because aluminium is plus 3, RO minus crisscross ಮಾಡಿ ಏನಾಗುತ್ತೆ Al OR, yes it is thrice, Al OR thrice, okay na? Again that is here how many, yes it is ORs are there 3, ಹಾಗಾಗಿ ಇದೇನಾಗುತ್ತೆ 3 ಆಗುತ್ತೆ, right? ಹೌದು ತಾನೆ? How many ORs are there 3, therefore 3 ಆಗುತ್ತೆ. Yes, ಹೌದಲ್ವಾ? ಈಗ ನೋಡಿ, if I say here 3 OR ಅಂತ ತಕ್ಷಣ ಹೈಡ್ರೋಜನ್ ಎಷ್ಟಾಗುತ್ತೆ 3 ಆಗುತ್ತೆ, ಬಟ್ ಇಲ್ಲಿ ಎಷ್ಟಿದೆ 2 ಇದೆ, ಅದನ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಬೇಕಲ್ವಾ, 2 ಅನ್ನು 3 ಮಾಡಬೇಕು. then go by this, go for it, 3/2 H2, 3/2 ಎಷ್ಟು ಅಂದ್ರೆ 3 hydrogens, here also we have 3 hydrogens, equation is balanced. But if you want to avoid this fraction, you multiply that whole equation by 2, again ಆಗುತ್ತೆ ನೋಡಿ, that is 6 ROH plus 2 Al. I am multiplying whole equation by 2, then it is 2 Al OR thrice plus 3H2. This is what we call it as action of aluminium on alcohols, and of course here also hydrogen gas is liberated, here also cleavage of OH bond takes place, right? And in the place of R, according to NCERT syllabus, I'll keep this tertiary butyl group. I'll keep tertiary butyl group. This is tertiary butyl group. Yes, R badlagi tertiary butyl group ಆಗ್ತೀನಿ. This is OH. In the remaining 2Al, right? 2Al. Then it is 2 times Al. Yes, it is O. O. Then it is C. CH3. Then it is CH3. Then it is CH3. How many times? 3 times plus 3H2. This is aluminium. This is aluminium tertiary butoxide. This is one of the alkoxide. This is what we call it as the action of aluminium on alcohols, action of aluminium and action of sodium on the alcohols is an example for the property where alcohol acts like acids, or you can say where there is a cleavage of OH bond takes place, right? So this is what we call it as acidic property of alcohols. Now at this moment I am going to compare acidic property of alcohols with that of the water. Acidic property of alcohols with that of the water. You know water, yes. What we say generally, water is amphoteric. It acts as an acid as well as base. And because it has an ability of donating H plus ions to other substances. Okay, right. If I say, if one hydrogen is replaced by any R group, that is electron releasing group. Again, R, yes it is R and it is OH. What is this? Alcohol. What is this? Alcohol. First of all, it is acidic. One hydrogen is replaced by R, that is electron releasing. Yes. If electron releasing group is there, yes it is delta minus and delta plus. Polarity of OH bond decreases. OH bond strength increases. Therefore, acidic strength decreases. Therefore, due to the presence of electron releasing groups, alcohols or OH is weaker acid. OH is weaker acid than water. Due to the presence of electron releasing group, here we don't find any electron releasing groups. Therefore, ROH is weaker acid than water. In order to justify this, I'll go for this RO minus. This is alkoxide. One of the alkoxide. Any R group for that matter. Yes. When RO minus is added to, yes, it is water. This is water. Yes. This is water. When RO minus is added to water, immediately what you will find? Yes. Immediately what you will find, and water gives off H plus, okay now, water gives off H plus and RO minus will take off H plus and becomes what we call it as ROH. Water gives H plus, that will be taken off RO minus, it becomes ROH, and then water will be converted to OH minus. So why I am writing all these things? Because on the basis of this, I am going to justify that water is stronger acid than alcohol. Okay, na? Yes. Here it is. We already said yes. Okay, na? We already said that is water is a acid and is stronger than, yes, it is alcohol. So if I say this is, if water, when it reacts with alkoxide, you are going to get alcohol. That means water displaces alcohol from alkoxide. That is, one acid displaces another acid from its compound. What kind of acids displace other kind of acids? Andre, one generalization is strong acid displaces weak acid from their compounds. Strong bases displace weak bases from their compounds. So the hagagi, if I say water displaces alcohol from, if water displaces alcohol from alkoxide, so water being a strong acid displaces weak acid from its compound. So alcohol is a compound of alkoxide and alcohol is obtained from alkoxide. Therefore, strong acid displaces weak acid from its compound. Therefore, alcohol is weaker than water. Now this is strong acid, is it not? Water is a strong acid. Therefore, its conjugate is what? What is that? OH minus. Its conjugate is what? OH minus. That is weak base. Conjugate of a strong acid is weak base. You studied that in first PUC. When strong acid releases H plus ion, gets converted to weak base. When weak acid releases H plus ion, gets converted to strong base. And reverse is also true. Andre, strong acid after giving H plus gets converted to weak base. The weak base, when it takes off H plus and gets converted to strong acid. Hagagi, being a strong acid, yes, after releasing H plus gets converted to weak base. ಹೌದಲ್ವಾ? ಹಾಗಾಗಿ ಇದೇ ರಿಯಾಕ್ಷನ್ ಇನ್ನೊಂದರ ಅರ್ಥ ಮಾಡ್ಕೋತೀನಿ. ಏನಪ್ಪಾ ಅಂದ್ರೆ alkoxide displaces OH minus from water ಅನ್ಬೋದು ಇದನ್ನ. ಇದೇ ರಿಯಾಕ್ಷನ್ ಯಾವ ತರ ಹೇಳ್ಬೋದು? Alkoxide displaces OH minus from water. Therefore, this base, alkoxide is a base that displaces OH minus, another base, from its compound. Therefore, as alkoxide displaces OH minus from water, it should be a strong base. Therefore, strong base displaces weak base from its compound. Hagagi, here in this particular reaction, I can conclude one more important aspect, that is alkoxide is a stronger base compared to the OH minus. Alkoxide is a stronger base compared to the OH minus. Athwa? Yes, it is. Water is a strong acid compared to alcohol. Water is a strong acid compared to, yes, it is alcohol. Therefore, on the basis of these two, what I can conclude at this moment is, right? Yes, it is RO minus is stronger base than, yes, it is OH minus. RO minus is stronger base than OH minus. R ಬದಲಾಗಿ C2H5 ಹಾಕಿ. C2H5O minus is stronger base than, yes, it is OH minus. ಅಥವಾ ಇಲ್ಲಿ Na plus ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ, yes, it is C2H5O minus Na. Sodium ethoxide is stronger base than NaOH. ಹೇಳ್ಬೋದಾ? If ethoxide is stronger base than OH minus, it means that sodium ethoxide is stronger base than NaOH. And yes, it is water is stronger acid. Water is stronger acid than, yes, it is alcohol. Water is stronger acid than alcohol. ನೋಡಿ ಎಷ್ಟು ಕನ್ಕ್ಲೂಷನ್ಸ್ ಅನ್ನು ನಾವು ಮಾಡಬಹುದು ಅಂತ ಹೇಳಿ. ನೋಡಿ ಇದು ಒಂದು ಸಿಂಪಲ್ ರಿಯಾಕ್ಷನ್ ನಿಮ್ಮ NCERT ಬುಕ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇದರಿಂದ ಇಷ್ಟೆಲ್ಲ ಕನ್ಕ್ಲೂಷನ್ಸ್ ನಾವು ಮಾಡಬಹುದು. ದಟ್ ಈಸ್ ಇವೆಲ್ಲ ನೀಟಾಗಿ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೆ ಎನಿ ಟೈಪ್ ಆಫ್ ಕ್ವೆಶ್ಚನ್ಸ್ ಕ್ಯಾನ್ ಆನ್ಸರ್ ಇನ್ ದ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್. ಹಾಗಾಗಿ ಇವೆಲ್ಲ ಕರೆಕ್ಟಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಇದ್ರ ಬಗ್ಗೆ ಸ್ವಲ್ಪ ಡೀಟೇಲ್ಸ್ ಹೇಳಿದೆ ನಾನು, ರೈಟ್? ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ acidic property of alcohols, right? And now at this moment we'll go to the under the headline properties of alcohols due to the, we have one more discussion, that is esterification reaction. What we call it as esterification reaction. We'll see that. That is esterification reaction. Esterification reaction is a kind of reaction taking place between carboxylic acids and alcohols. When carboxylic acid, right? When carboxylic acid, this is carboxylic acid. Any compound containing COOH group is called carboxylic acid. This is carboxylic acid. When it reacts with, yes, it is alcohol. This is alcohol. ಸ್ವಲ್ಪ ಬರೆಯೋ ರೀತಿಯನ್ನು ಸ್ವಲ್ಪ ಗಮನಿಸಿ. ನಾವು ಈ ಥರ ಬರಿತೀವಿ ಆರ್ ಓ ಎಚ್ ಅಂತೇಳಿ, ಹೀಗೂ ಬರಿಬೋದು, ಏನು ತೊಂದರೆ ಇಲ್ಲ. ಆದರೆ ಪ್ರೊವೈಡೆಡ್ ದೇರ್ ಶುಡ್ ಬಿ ಅ ಡೈರೆಕ್ಟ್ ಲಿಂಕೇಜ್ ಬಿಟ್ವೀನ್ ಆಕ್ಸಿಜನ್ ಆ್ಯಂಡ್ ಕಾರ್ಬನ್. ನೀವು ಹೀಗೆ ಬರೆದ್ರೆ ತಪ್ಪು, ಮತ್ತೆ ಹಿಂಗೆ ಬರೆದ್ರೆ ತಪ್ಪು. ದಿಸ್ ಇಸ್ ರಾಂಗ್, ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ರೈಟ್, there should be a linkage between oxygen and carbon. Yes, okay. And of course this reaction is carried out in presence of concentrated sulfuric acid. Reaction is reversible. Then what happens, OH from acid, H from alcohol. Gamnisi, there is a cleavage of OH bond takes place. E bond break agate, alcohol in the OH bond break agate. Properties due to the cleavage of OH bond. Yes, and if it is so, then R C double bond O R dash plus, yes, it is H2. R dash is one more alkyl group. Yes, just to differentiate R from R dash, I have written there R dash there. Okay, na? The carboxylic acid, when it is heated with alcohol in presence of dehydrating agent like concentrated sulfuric acid, then you are going to get ester. So as far as ester is concerned, known for pleasant smell, known for fruity odor. Therefore, the chemical reaction is called esterification, and such type of chemical reactions will be identified on the basis of fruity smell. The main observation of this reaction is fruity smell or fruity odor. So that is what we call esterification reactions, right? And in this reaction, I use concentrated sulfuric acid because it removes water, because concentrated sulfuric acid is a dehydrating agent. When water is removed, according to Le-Chatelier's principle, when an equilibrium is disturbed by changing concentration, temperature and pressure, then it will be shifted in that direction in which effect of disturbance is cancelled. In that manner, look at this. If I remove water, in order to compensate that, equilibrium will be shifted in forward direction. Okay, na? So that's why concentrated sulfuric acid is used here. And of course, and you can have one example. In the place of R, you keep CS3. R ಬದಲಾಗಿ CS3 ಬರೀರಿ, R dash ಬದಲಾಗಿ C2H5 ಬರೀರಿ. Alkyl groups, both are alkyl groups. Then you write this is CH3, C double bond O, OH plus HO, C2H5. This is ethanol. This is ethanoic acid. This is ethanoic acid. This is ethanol. Yes. Look at this. In presence of concentrated sulfuric acid. In presence of concentrated sulfuric acid. Yes. Look at this. Same thing will happen. Then you are going to get CH3, C double bond O, and it is C2H5 plus H2O. This is ethyl ethanoate. Ethyl ethanoate. Suffix for the esters is O8. Ethyl because of this. Eth because of two carbon. Ethyl ethanoate. So this is. When acetic acid reacts with ethyl alcohol, you are going to get ethyl acetate. Common names. So this is what we call it as esterification reaction. Okay now? And this esterification reaction can also be brought about by using some chemical substances called what we call it as acid anhydrides. I can also bring about this reaction by using acid anhydrides. Right? Acid anhydrides are of this type, right? Or C double bond O. Yes, it is C double bond O, and it is R. This is acid anhydride. Yes. When acid anhydride, instead of carboxylic acid, I am using acid anhydride. Yes. When acid anhydride reacts with alcohol, when acid anhydride reacts with alcohol, same type, OH bond break agate. Again agate nodi. Or C double bond O, OR dash. Or C double bond O, OR dash. Or C double bond O, OR. Remaining is, yes, it is R C double bond O, OH. This is carboxylic acid. Yes. This is also esterification, but here I am using, yes, it is acetic anhydride, and of course I have introduced here it is acyl group in this particular reaction. Therefore, this reaction is also called as acylation. This is also called as acylation reaction. Yes, if the esterification is brought about by using acetic anhydride or acetyl chloride, the reaction is called as acylation. Yes. So this is what we call acylation. But I want you to write the equation, the same type of equation, example for this, by taking R as CS3, R dash as C2H5. Never baribeku. So this is what we call it as esterification. Yes, that is by using, yes, it is acid anhydride. Agboda. Here also, the main role of concentrated sulfuric acid is to remove, yes, it is carboxylic acid from the equilibrium, so that equilibrium can be shifted in forward direction. Yes, now at this moment, we'll go for the one more, yes, it is, yes, a reaction where also you will find esterification, where also ester is produced, but esterification is carried out by using acid chloride. This is or C double bond O Cl. This is acid chloride. Observe body. You can bring about esterification either by using carboxylic acid or by using, yes it is, or by using, either by using carboxylic acid or by using acid anhydrides or by using acid chlorides. Okay na? Now look at this. OH bond breaks, HCl is taken out, and of course this is HCl, right? Here also, this is also an example for acylation, but here HCl is produced here as a side product that cannot be removed by concentrated sulfuric acid. Therefore, acylation is carried out by using pyridine, because pyridine is a weak base that can remove strong acid like HCl. If HCl is removed, equilibrium is shifted in forward direction, and that is what we call it as acylation reaction. And of course, acylation reaction, that is esterification reaction, brought about by using acid chloride. Here also, if I keep this R as CS3, CS3 is COCl, this is ethanol chloride. This is ethanol chloride. IUPAC name plus, yes it is R dash plus C2H5, that is ethanol, right? Reaction is carried out in presence of pyridine. If pyridine is used, yes it is, HCl is removed, and of course you are going to get CS3, C double bond O C2H5, ethyl ethanoate, and of course this is ethyl ethanoate. Ethyl ethanoate. This is what we call it as one more example where also esterification takes place, where also OH bond breaks, where there is a cleavage of OH bond in the case of alcohols, right? But esterification is brought about by using acid chloride, and that is what we call it as the reactions where there is a cleavage of OH bond is observed. And apart from that, I want to give one important information as far as reactivity of alcohols are concerned. Yes, reactivity of alcohols towards the cleavage of OH bond. Yes, in these reactions, in the case of reactions where there is a cleavage of OH bond, with respect to this reaction, right? Reactivity order of alcohols. Look at this. Primary alcohols are more reactive than secondary alcohols. Secondary alcohols are more reactive than, yes it is, tertiary alcohols towards the cleavage of OH bond in the case of alcohols. Because here we have one electron releasing group is there, here we have two electron releasing groups are there, here we have three electron releasing groups are there. When number of electron releasing groups increases, that OH bond becomes very, very strong. OH bond becomes very, very strong. As the number of electron releasing groups increases, electron density between O and H increases, OH bond becomes very strong, then the breaking of OH bond becomes difficult. Therefore, the tertiary alcohols are least reactive towards cleavage of OH bond. Primary alcohols are more reactive towards cleavage of OH bond, and that is what we call it as reactivity order. So with that information, yes, we'll go to the next topic, that is the chemical reactions of alcohols, properties of alcohols due to the cleavage of CO bond. Yes, that is the next topic. Yes, the properties of alcohols due to the cleavage of CO bond, right? Look here, in this type of reaction, right, generally we make use of protonated alcohols. Such type of reactions will be carried out by using protonated alcohols. Protonated alcohol we use, right? Look at this. When alcohol is protonated, this is alcohol. When it is protonated, you are going to get or CH2 OH2 plus, because lone pair of electrons will be absorbing H plus. Lone pair of electrons will be absorbing H plus, and you are going to get or CH2 OH2 plus. This is protonated alcohol. Yes. Then yes, it is the compound like like Br minus, for example, right? When it attacks this, yes, it is or CH2OH2 plus, right? Okay, now due to the presence of this positive charge, electron density will be moving towards OH2 plus, and then this will be taken out in the form of H2O. Okay, now all the electron densities will be completely moving towards oxygen, because oxygen is highly electronegative with positive charge. Again, carbon gets positive charge and it will be attacked by Br minus. Then the result is you are going to get or CS2Br plus H2O, and of course sigma electrons are going to neutralize positive charge of the oxygen, and you are going to get, yes, it is or CS2Br. Means what? So whenever protonated alcohols are used, which bond has broken here? CO bond. Actually CO bond has broken, and because of that protonation of alcohol. Yes, and this is what we call it as protonated alcohols. Here protonated alcohols will be acting like electrophiles. Andre, in the case of reactions where there is a cleavage of CO bond takes place, in such type of chemical reactions, right? In such type of chemical reactions, right? That protonated alcohol acts like a electrophile. In the case of cleavage of OH bond, alcohol was acting like a nucleophile, but here it is acting like an electrophile. That you have to remember. Yes. So that is what we call it as. And the reactions of alcohol and where there is a cleavage of CO bond takes place, in these reactions the protonated alcohols will be used in a chemical reaction. Is it not? And of course I'll go for one such example for the reaction where there is a cleavage of CO bond takes place, and that is what we call it as action of hydrogen halide. Action of hydrogen halide, HX, where X can be iodine, X can be bromine, or X can be chlorine. This is what we call HX, right? Observe here, when alcohols, right? When alcohols react with HX, okay, na? Then what happens generally? Yes, it is H2O is taken out, and of course you are going to get RX plus H2O, right? Remember here our CO bond has broken. CO bond has broken. Yes, OH is replaced by X. That's why it is a cleavage of CO bond, and of course it will be carried out in presence of strong dehydrating agents. Certain strong dehydrating agents will be used, so that yes, it is the CO bonds can be weakened. Yes, and under this particular headline now, I am going to discuss what we call it as action anhydrous, and that is action of Lucas reagent. I'll go for action of Lucas reagent. This is the example to be discussed. As far as Lucas reagent is concerned, Lucas reagent is mixture of anhydrous ZnCl2, zinc chloride, and concentrated HCl. You remember, generally students will say mixture of anhydrous zinc chloride and HCl is called as Lucas reagent anta heltare. Tappu. You must use the term concentrated HCl athwa HCl gas. Mixture of anhydrous zinc chloride and concentrated HCl is taken as yes, it is Lucas reagent. Yes. What happens you have an alcohol, yes, it is reacts with, yes, it is HCl in presence of anhydrous zinc chloride, yes, in presence of anhydrous zinc chloride, yes, and of course cleavage of CO bond takes place, and you are going to get chloroalkane, that is RCl plus H2O. This is chloroalkane. Okay, na? Yes, actually what happens and in this particular reaction we have lone pair of electrons, right? And of course anhydrous zinc chloride is there, right? Anhydrous zinc chloride is there, right? Yes, it is zinc chloride being Lewis acid, yes, being Lewis acid. It is going to accept the electron pairs donated by the alcohols. It is going to accept the electron pairs donated by the, yes, it is alcohol, and if it is so, if ZnCl2 is attached to, yes, it is O, this bond becomes weak. CO bond becomes weak. Okay na? If CO bond becomes weak, cleavage of acidity CO bond takes place, and that is what we call it as action of acidity Lucas reagent. And remember, and this reaction, yes, where you are going to get chloroalkane, which is insoluble in water. Yes, chloroalkane is insoluble in water. Yes, chloroalkane is insoluble in water. Because of that, when Lucas reagent reacts with alcohols, that is due to the formation of this insoluble chloroalkane, and you will find the formation of turbidity. That is, transparency of the water medium decreases. Due to the formation of insoluble chloroalkanes, the transparency of the water decreases. That is what we call water clear agiruttallva. Agenagatte dull appearance barutte. Andre that is transparency of water decreases. That's why it is called turbidity. That means when alcohols react with Lucas reagent, you are going to get the chloroalkanes which give turbid appearance to the water. That's why, and as far as alcohols are concerned, when alcohol react with Lucas reagent, you are going to get that is turbidity there. And remember, towards this particular reaction, towards the reaction, there is cleavage of, yes, it is CO bond. For this particular reactions, tertiary alcohols are more reactive than secondary alcohols. Tertiary alcohols are more reactive than secondary alcohols. Secondary alcohols are more reactive than primary alcohols, because in such type of chemical reactions, there is a formation of carbocation, right? There is a formation of carbocation or OH. Okay, na? Yes, it is. You are going to get, yes, it is H plus. Right? They will be denoted like this. You are going to get R OH2 plus, right? And it will be taken out, and you are going to get R plus. The reaction proceeds through the formation of carbocation. But tertiary alcohols will form highly stable carbocation, that is tertiary carbocation, right? If I say this is tertiary alcohol, it is going to form tertiary carbocation. If this tertiary carbocation is stable, tertiary alcohol will be more reactive. If this tertiary carbocation is more stable, tertiary alcohol will be more reactive. Therefore, tertiary alcohols are more reactive than secondary alcohols. Secondary alcohols are more reactive than primary alcohols. If I say primary alcohol, that produces primary carbocation, which is less stable. Therefore, primary alcohol is less reactive. And because of that, tertiary alcohols are more reactive than secondary alcohols. Secondary alcohols more reactive than primary alcohols towards the reactions where there is a cleavage of CO bond takes place. And therefore, when alcohols react with Lucas reagent, tertiary alcohols give turbidity immediately because they are more reactive. Secondary alcohols give turbidity after 5 to 10 minutes. Primary alcohols give turbidity only after heating, only upon heating, because primary reaction that we use for differentiating primary, secondary and tertiary alcohols. For your information, sir, correct artha madkoli, we discussed two reactions here. Here, reactions due to the cleavage of OH bond, where primary alcohols are more reactive. Here, in the case of reactions due to the cleavage of that is CO bond, where tertiary alcohols are more reactive. Idanna our difference in a notice madana. So in the next video we'll see, yes, it is one more kind of reaction where there is a cleavage of CO bond takes place. Agboda? Thank you.